Hi, in this video we will introduce the notion of determinant for square matrices, and in particular we will see how to compute this determinant for 1 by 1 and 2 by 2 matrices. Well, determinant is defined only for square matrices, so let me assume that A is an n by n matrix. And well, what do we want to do here? We want to assign to any square matrix a number, determinant of A. Well, this number, computing this number is not easy, and it will take several videos to have the general formula or how to compute this number for general n by n matrix. But when we are done with that, we will see the properties of determinant and why this notion, the determinant, is important. Okay, so for 1 by 1 matrices, so this is maybe the first time I'm talking about 1 by 1 matrices. So 1 by 1 matrix is what? So this guy is going to be, well, just one number. It will have one entry. The determinant of that will be, well, there's only one thing here. This will be easy. Just that number. 1 number. But when it comes to 2 by 2 matrix, then we have, well, 4 numbers in such matrix. What do we do with this? Or how do we get that determinant of, let me call this one A, determinant of A in this case? Well, the formula is you multiply entries on the main diagonal, so A11 times A22. Then subtract from that the product of diagonal entries, so A12, A21. Multiply diagonal entries minus off diagonal entries. Okay, this is how we find the determinant of 2 by 2 matrices. For other dimensions, you will see that how it works later. Let's just do some examples before we finish this video. So here we have 2 by 2 matrix. The determinant is you multiply entries on the main diagonal minus entries off diagonal. So this is 3 minus 0, which is 3. Just one number. Determinant of any square matrix is a number. Here, this is 3 times 1 minus 4 times 2. It's 3 minus 8, which is negative 5. Main diagonal, negative 1 times negative 6 minus off diagonal product, so 2 times 3. This is 6 minus 6, which is 0. Yes, determinant can be 0. And even if the entries are or have some variables, it doesn't matter for us, so you would just multiply x times x minus 1 minus 2x plus 1 times 3. So this gives us x squared minus x minus 2x, minus 6x minus 3, which together is x squared minus 7x minus 3. And well, let's do another example in which we are trying to find values of k such that the determinant of this 2 by 2 matrix is 0. So let's first find that determinant. This is 2k1, k minus 3, 2. Main diagonal entries, so 2k times 2 minus off diagonal entries. Here, so 4k minus k plus 3. And we want to find entries of this guy, values of this guy, which makes determinant 0. So it means that we need to see for what values of k, 3k plus 3 is 0. And that means that 3k is equal to negative 3, which means that if I plug in k equal to negative 1, then determinant of this matrix will be 0. Well, the determinant of 3 by 3 matrix and higher dimensions will be discussed in other videos.